Today I'll be presenting a talk based on my paper titled What Was So Unique About Ancient Indian Astronomy? This presentation aims to investigate the antiquity of ancient Indian astronomy and India's contributions to the field. We aim to try to answer the question of how far back Indian astronomical knowledge originated and what is the extent of its contributions to the field. So we will be looking at the antiquity of Indian astronomy, the Vedas, Surya Siddhanta and Aryabhata, contributions of ancient Indian astronomy, and challenges. So what is astronomy? Astronomy is the branch of science that focuses on estimating the positions and motions of celestial bodies. The common belief is that the Astro-Babylonians, around 1000 BCE, made the first systematic astronomical observation of celestial bodies. This was followed by Greek scholars and then Persian and Chinese ancient astronomers. Little mention is made of ancient India's key contributions to the field. However, when we look at the Vedas and Siddhantas, such as Aryabhata and Surya Siddhanta, there are clear mentions of astronomical events from many millennia ago, mentioning some events from as far back as 21st millennium BCE. It would be nice to know the truth. So the primary purpose of Indian astronomy has been to understand direction, location, and time. Dik Desa Kala Jnana. Indian astronomy has developed from the period of the Vedas, Vedaka Jyotisha, to the present-day Siddhartha Darpana of Srimanta Chandrasekhara. These ancient texts, such as the Vedas and Upanishads, were used to calculate the motions of the sun and moon, as well as their movement across rasis and nakshatras. The Indian calendar Panchanga played a crucial role in determining dates and times for various social, religious, and cultural functions. The Panchanga pervades the daily life of the people. There are approximately 15 different calendrical systems prevalent till date. This is a big purpose of ancient Indian astronomy, as it determines the dates and times. Jyotisha Shastra consists of cosmology, cosmogony, earth studies, astrometry, planetary studies, time studies, and uses yantras, which are instrumental tools to model celestial movements. So Panchanga is purely based on astronomy. All items in Panchanga refer to time units that require advanced mathematical models. This is used by people all over India even today. It talks about many elements of time, and most importantly, the following 5 items: Tithi, Nakshatra, Vara, Yoga, and Karana. Whereas the Gregorian calendar is completely arbitrary and has no reference to astronomy. So how far does ancient Indian astronomy go? Does it predate other astronomical civilizations? Well, the Rig Veda, believed to be the earliest of the Vedas, has been of interest of researchers who have done extensive work to find its antiquity. Some have concluded that the Rig Veda mentions events that are at least 21,000 years old. Surya Siddhanta researchers have found references in the text to the longitude of nakshatras around 580 CE, the obliquity of the Earth's axis around 2900 BC, the equation of the Sun around 5300 BC, the latitude of nakshatras around 7500 BC, the 2 pole stars around 12,000 BC, and up to 28 to 27 nakshatras around 14,500 BCE. Research also indicates that Surya Siddhanta is at least 14,500 years old, and updates go even far back up to 38,000 BCE. I would like to credit Mr. Nilesh Oak for these references. In the Chandogya Upanishad of the Samaveda, during a discussion between Guru Sanat Kumara and student sage Narada, Narada answers a question asked by the Guru. Before I teach you, I would like to know what have you learned so far. Sage Narada lists various fields of knowledge that he has learned, and one of which is the knowledge of astronomy. Narada mentions this sloka as Nakshatra Vidya, which is the science of stars. This shloka shows clear evidence that knowledge of stars have been known to even students since Vedic times. I read the sloka said by Sage Narada. Rigvedam Bhagava Adhyami, Yajurvedam, Samavedam, Atharvana Chaturtham, Itihasa Puranam, Panchamam, Vedanam Vedam, Pitryam, Rashim, Devam, Nidin, Vako Vakyam, Ekayanam, Deva Vidyam, Brahma Vidyam, Bhuta Vidyam, Kshatra Vidyam, Nakshatra Vidyam, Sarpacha Devajana Vidyam, Etad Bhagava Atyeni. So the Rig Veda talks about the moon's orbit that is divided into 27 equal sections, each of which is called a nakshatra. The Satapada Brahmana in the Rig Veda describes 34 lights, which are interpreted to be the sun, the moon, the 5 planets, and 27 nakshatras. The Rig Veda also mentions the sun as being a star. It portrays the sun as the sole source of light in the universe, responsible for changing seasons and the lord of the world. According to Adharya Brahmana, the sun also generates wind. Gravity is also mentioned in the Rig Veda. The Rig Veda explains the gravitational effect of the solar system keeps the earth stable. Now I would like to talk about an important event recorded by the Rig Veda. So the Rig Veda recorded an astronomical event from 7176 BCE. Even though it is coded in the form of an allegorical tale, it indirectly records the time period of a very massive solar flare in the form of coronal mass ejection, which caused brilliance in the skies all over Earth, and everyone is affected by it. Just recently, scientists calculated the date of this massive event to be 7176 BCE. So the Vedic recording of this event was encoded in an allegorical tale. Samjana, the wife of the sun, moved far away from him. The sun goes south in search of her and finds her in the Tropic of Capricorn. They reunite and have twin sons Ashwins, which symbolizes their helical rising in the morning sky. Plugging this planetary arrangement into any software yields a date close to 7176 BCE. Surya Siddhanta, an ancient book on astronomy full of highly advanced and accurate treatises, made many great contributions to astronomy. Surya Siddhanta is globally renowned for its advanced scientific and astronomical understanding of the universe. The text describes rulers to calculate the motions of various planets and the moon relative to other constellations. It describes the Earth as a spherical shape and calculates the Earth's diameter as 8,000 miles, the moon's diameter as 2,400 miles, and the distance between the moon and the Earth as 258,000 miles. It also gave the estimate of 54 arcseconds per year and the Earth's wobbling due to the precision of the equinoxes. Surya Siddhanta has said that there are 2 pole stars, one each around the north celestial point and south celestial point. It also talks about the Earth's obliquity being 24 degrees. Now let's talk about an important astronomer who made many great contributions and also explained astronomy from the Vedas in detail. In the 5th century BCE, the notable Indian astronomer Aryabhatta introduced a new solar system model, positioning the sun in the center of the universe and explaining that the Earth is round. This is the heliocentric model. This heliocentric model was groundbreaking for its era. Aryabhatta also noted that the ratio between the rotations of the Earth and lunar orbits to be approximately 27.39, which stands as one of the earliest calculated astronomical constants with such high accuracy. He also estimated the length of the Earth shadow, the Moon shadow, and the duration of the eclipse. He explained shadows, Rahu and Ketu, as ascending and descending nodes. Aryabhatta has also made tremendous contributions to astronomy through the use of mathematics. Some of them include Aryabhatta giving the approximate value of pi, devising a math formula to estimate the duration of a year, and solving many difficult equations to make astronomical contributions. Other contributions of Indian astronomy include the lunisolar and sidereal calendars. This helped decode events in Vedic literature. For example, the Mahabharata states Bhishma passed away during the lunar month of Falgu at the start of Uttarayan, which occurred on 31st January in the Mahabharata period. Today, the winter solstice falls on December 21st, with the lunar month being Margashishra. Since then, about 3.5 lunar months and rasis have shifted away from the winter solstice. Another contribution is the calculation and prediction of eclipses. In an instance in the Rig Veda, Maharishi Atri predicted that a solar eclipse would occur. The eclipse he observed is estimated to have occurred either in 4677 BC or 4202 BC. It is interpreted that the Rig Veda is talking about Atri using a Turiya device to estimate the angle between the sun and the moon. Atri had understood the eclipse model to predict when eclipses would occur, which is when the angle between the sun and moon is 0 degrees. Now let's discuss how ancient Indian astronomers determined and used the celestial circumference for GPS and navigation. Let's look at the importance of the 3438 radius. The number of 3438 came from mathematical sophistication with naked eye resolution. The circumference of a celestial sphere is 21,600 arc minutes. If you take the circumference and divide it by 2 pi, you get the radius of 3,438. Now, why is this even significant? This calculation allowed navigators to determine distances traveled and positions on Earth by estimating arc minutes from a particular star. This discovery was way ahead of its time, and this phenomenal number is used in all tables of Surya Siddhanta. In Rigvedic times, a ship's captain could figure out how far the ship had traveled by observing the sun during the day and the stars at night. This was also employed for astronomical calculation and time units. So what challenges came in determining Indian astronomical contributions? Of course, Western civilizations influenced this. When Western civilizations became aware of Surya Siddhanta around the 18th century CE, they translated the text claiming that Surya Siddhanta was a 1500-year-old text. They made hasty and incorrect assumptions when dating Surya Siddhanta. This played a humongous role in shaping what society today thinks about in regards to India's astronomical contributions and antiquity. Although the Greeks are credited for most astronomical and mathematical achievements, they were very late in grasping concepts that are mentioned in the Vedas and Rishis, like Yajnavalkya around 2800 BCE. In the Homeric tradition written by the Greeks, it is claimed that the earth is flat and floating on water. Even in 300 BCE, Pythagoras did not know what the earth rested on. Aristotle also didn't understand what the earth was resting on and didn't have any concept of gravity, much like Archimedes. On the other hand, the Rigveda and the Brihadarika Upanishad articulated the concept of gravity much before the Greeks and Isaac Newton ever did, which is something that's not commonly known. To summarize, Indian astronomy was very advanced and developed since ancient times. Evidence indicates that it was developed many millennia before the ancient Greeks. Many concepts like time dilation, relative movement of stars, and determining one's position on Earth were known by Indians way before the current world. Most of ancient Indian knowledge is preserved in its vast Vedic literature, which was handed down orally by clans dedicated to certain works. It is high time that we embrace, educate, and benefit from Indian astronomy, and in general the knowledge encoded in Vedic literature. Thank you and namaste.
Such a wonderful talk. Question, 1 second, sir. Have you quoted Dr. Nilesh Yoko? Have you met him?
Yes,
One time, okay. He's here too. You're the one he's going to get after you. So,
I also took stuff from Dr. Raj Vedam.
yes, I was going to say, who is here to and you're doing such a wonderful job.
Can we ask a question?
Yes.
So, you mentioned about direction and, for the navigation. So, what I believe that Indian has been navigating the sea since at least last ice age, which was about 10,000 years ago. But Europeans did it like last 700 years or something. So, we have been navigating the sea, obviously based on mathematics and our stars and all that, right? So that is itself a proof that we have been basing on that. So I have not read too much. You are the first person you talked about it, some. But and one place I saw that we have been navigating the sea. That is the reason all the world languages, even the native language here, they are affected by Sanskrit. Sanskrit is the mother language all over because Indians have been traveling and grading and all that. So all that has to be related.
Actually, the word navigation came from Sanskrit, the Sanskrit word, And Indians have been navigating the seas for much before the Greeks and Western has ever done, because they used number 3438 and also used astronomy from the Vedas, Rig Veda, Surya Siddhanta. They were using it so they know where they're going.
Tell them about your paper tomorrow morning on navigation. Tell them.
Okay, yeah.
That
Can you
is
speak about that for a minute? You want-
Yeah. So tomorrow, my brother and I will be presenting a paper on maritime activity and navigation in ancient India.
Oh,
Yeah.
And now we'll move on to our great auditor, Sri Nilesh Bhokti.